all, welcome back to Excel's Rapid Focus series. It's me, Fairul Rahman, your math faculty. Today, we are going to discuss the chapter, Applications of Derivatives. It's the toughest chapter, isn't it? Why it is that much tough? Because, listen, this is the reason. Because types of questions is like this, rate of change of quantities. I think this thing you can easily do if you know the continuity and differentiability part. It's just differentiating things and relating things. I will explain these kind of questions. And the second type of question is what? Increasing and decreasing. There is two types of questions that you can expect from it. One is interval type. You want to find the interval, that kind of one. And another one, inequality. You have to use inequality to check the function is increasing or decreasing. And the third one is what? Maxima and minima. This is the biggest one. This is the king player. What is it? What is it? Because from this part you can expect big mark questions. So they may ask you direct question, or they will give you a two variable function, and you have to convert that back into single variable function to check whether the function is maximum and minimum at where. And word problems, I will give you some situation. From that you have to create an equation that is two variable function, then you have to convert back into one variable, and they will give you a word problem. From that you need to show that or prove that or find something. So when a volume is maximum, you have to find the radius is this. When the surface area is maximum, you have to find the radius is half of the height, that kind of question. And the last topic is absolute maxima and absolute minima. The absolute maxima and absolute minima only if they ask you to find the maxima and minima within an interval. They will give you an interval. So I will explain all these kind of questions, and stay tuned. So just share this video to all your friends, okay? Because I'm not just taking the concepts, I'm just giving you an idea about the types of question that you can expect. So different types of question, same topic. One topic you can expect 4 types of question. So I'm explaining the types of questions here. So please share it to all your friends. And okay, without wasting time, we can move into the first question. The first question is from the topic rate of change of quantities. What is rate of change of quantities? Actually, I think you all know what is dy by dx. What is dy by dx? Change in y. What is at the denominator? X is at the denominator. So change in y with respect to x. So y is changing with respect to x. That means when x is changing, y is also changing at a specific rate. Or in other words, you can write another thing here like this. Here, change in x. X is changing with respect to theta. X is changing with respect to theta. So while theta is changing, the value of x is also changing. But in this topic, we are discussing about rate of change of quantities. The word rate is relay on time. So I will give you one example here, that is ds by dt. Let's call s as displacement. Change in displacement. Look at here, change in y at the numerator, change in x at the numerator. Here what is it? Change in displacement with respect to time. I think you all know what it is, velocity. So when the denominator comes to t, or the changes relay on time, we call it rate of change of quantities. But in some questions, they will change the quantity that we are measuring to x or theta. Okay, we can look into that kind of questions also. So here, the first question is what? The median of an equilateral triangle is increasing at the rate of 2√3 centimeter per second. So we need a triangle, equilateral triangle. So here is the equilateral triangle, and the median of an equilateral triangle is increasing. So the median is increasing. So we need the median. So what is the median? From one vertex to a perpendicular to the opposite side is called median. So the length of the median, you can see the length of the median, AM, I'm calling it y. So what is AM? AM is equal to y centimeters. and it's an equilateral triangle, all the sides will be what? All the sides will be what? X centimeters. A, B, C. Ready? So just focus here. These are the information they have given. It's an equilateral triangle, all sides are what? Equal, and they have given the median is changing at the rate of 2√3 centimeter. Changing means increasing, specifically increasing. The change may be increase or decrease, but they specifically said it's increasing. So who's changing? Median is changing. Whose median? M is median. M is what? Y centimeter. So change in Y. Who's changing? Y is changing with respect to what? Time, because it's rate centimeter per second. Distance, the length with respect to time, the length Y with respect to time. They have given it's 2√3 centimeter per second. 2√3 centimeter per second. So if they set decreasing instead of this increasing, if they given decreasing, you have to put what? Negative. If the change is decreasing, you have to put what? Negative in front of it. Now it's increasing, so you don't need to put what? Negative in front of it. And what they need to find the rate at which its side is increasing. We need to change when the length of median is increasing, the sides also need to be increased to adjust. So we need to find dx by dt. That's what they asked for. Dx by dt, that's what they asked for. So find the rate at which its side is increasing. That is dx by dt. The length of one side is what? X. Length of all sides is what? X, because it's an equilateral triangle. So we need to relate this y and this x. First, if you got a question like this, we need to create an equation that relates y and x. So how do we get that? Listen to the figure. Can you see the triangle ABM? From triangle ABM, from ABM, what is this length BM? BM is x by 2, half of it, x by 2. Then BM is x by 2, AM is y, and AB is x. You know Pythagoras theorem. It will be x square is equal to x by 2 the whole square plus altitude square, that's y square. So now we got an equation that relates y and x. So I'm going to take this part to here, the x part to here. So x square minus x square by 4 plus y square, equal to x square by 4 is equal to y square. Then I'm going to take this x square out. So you will get 1 minus 1 by 4 is equal to y square. Cross multiplied, you will get x square into 3 by 4 as y square. Now you got an equation that relates x and y. Now differentiate this with respect to t. So differentiating x square with respect to t, you will get 2x, but it is not t, it is x. So you have to do implicit differentiation, that is dx by dt will be there. And I already took this constant out, 3 by 4. First took the constant out. Then derivative of y square is what? 2y into dy by dt. It's not t, therefore we have to use the implicit differentiation. So this is cancelled. So you will get what? 3 by 2 x times dx by dt. Dx by dt, that is the thing that we need. 2 times y into dy by dt. Dy by dt is given, that is 2√3. So into 2√3. But the problem is you are not able to find dx by dt from it. Why? Because we have x, we need x and y. So what we can do? So here, this is the expression that we got. So I need dx by dt from it. Dx by dt from it. So 2y into 2√3, it will become 4√3y, and this will go there, and it will be 2 by 3 divided by this, x will go here. So when I simplify it, what I'll get? 8√3y by x. 8√3 by 3 will be there. Okay, so if I got y by x also, I will get what? Dx by dt. From where I will get y by x? Listen, here we already got x square into 3 by 4 is equal to y square. So here it is what? X square into 3 by 4 is equal to y square. It's here. So 3 by 4 will be equal to y square by x square. So what is y by x the whole square? It is 3 by 4. So y by x will be what? Root 3 by root 4. That is root 3 by 2. So y by x is what? Root 3 by 2. You got that? So we can substitute it here. What you will get? 8 root 3 by 3 into root 3 by 2. That is y by x root 3 by 2. So 3 and these two root 3's will be cancelled because root 3 into root 3 is 3 and these two will be gone. You will get 4 centimeter per second as the change of side. Okay, so this will be your answer. Dx by dt is equal to 4 centimeter per second. Then the rate at which the side is increasing when the median increases at the rate of 2 root 3 centimeter per second. This is one kind of question from rate of change of quantities. So we can move into the next type. Here the next question is, a man 1.6 meter tall walks at the rate of 0.3 meter per second away from a street light. Okay, so there is a street light. Let's draw this figure. Let's draw it. Here there is a ground. We need to place a street light here. So this is a street light, and one man is walking away from the street light. So suppose maybe he reached here, and they have given the height of that man is 1.6 meters and walks away from the street light, that is 4 meter above the ground. So that means from this ground the street light is here 4 meter above. 4 meter above. Ready? So walks at the rate of 0.3 meter. So listen, this is the distance between the street light and the person. I'm calling it x. So what they said, this person is moving away from the street light at the rate of 0.3 meter per second. That means this distance is changing. This distance is changing at the rate of what? 0.3 meter per second, because he is walking away from it. Walking away means this x is changing. Ready? So the change of x is at the speed of 0.3 meter per second. So I can write it, dx by dt is given, that is 0.3 meter per second. Meter per second. This is given. Ready? Then what is the question? At what rate is the at what rate is the tip of its shadow moving? Tip of its shadow. So let's check what they mean by tip of its shadow. So if the light ray is coming from here, this is its head, and the light will create a shadow with the length. This is the length of the shadow. This is the length of the shadow from the foot of the person to here, because the light is coming from here. The shadow of this person will be like on the floor till this distance, y distance. And what they need to find, what rate is the tip of his shadow is moving. Tip of his shadow. So when he moves a little bit forward, the shadow is again moving forward. The length of the shadow is increasing. That means the tip is moving. So we need to change, we need to check, we need to find the rate of change the tip of the shadow is moving. That is the question. That is the first question. And what is the second question? At what rate is shadow lengthening? That means at what rate y is increasing. The length of shadow is what? Y. So the question, what rate is shadow is lengthening? That means the y is increasing at what rate? That is the question. So to do that, you need to relate x and y. What we have done in the last question. We create an equation that relates x and y, two variables in it. So like this, here also, in this question also, we have x and y. X is what? The distance from the street light to the person, and y is what? The distance from the person to the tip of his shadow. So we need to relate these things. So I'm naming these vertices A, B, C for the bigger triangle and D, E, C for the smaller triangle. So from triangle ABC and triangle DEC, from the bigger triangle and the smaller triangle, they are similar because this angle is common and they have a 90 degree. Similar triangles. So similar triangles means their sides are proportional. Sides are proportional means AB by this length DE will be equal to this length, what is it, BC by this length, that is EC. So you know what is AB. AB is what? 4. DE is what? D is what? 1.6. And BC is what? X plus Y. And EC is what? It's just Y. Ready? I'm taking this Y to this side. 4Y is equal to 1.6 times X plus Y. Open the bracket, what you will get? 1.6 times X plus 1.6 times Y. It's 4Y. I'm taking this 1.6 times X to this side. 4Y minus 1.6 times Y is equal to 1.6X. I'm taking the Y out. So 4 minus 1.6 is equal to 1.6 times X. Ready? So 4 minus 1.6, you will get Y into 2.4, or you can write it like 2.4 times Y is equal to 1.6 times X. So you got a relation between Y and X. All good? So about 2.4 times Y is equal to 1.6 times X. So we already got dx by dt. Now we need to find dy by dt. How do you get dy by dt from it? Listen very carefully. Listen. If I differentiate both sides, what I'll get? 24 times dy by dt. It's not 24, it's 2.4 times differentiating y with respect to d, that is dy by dt, is equal to 1.6 is there, 1.6 differentiating x with respect to d, so you will write dx by dt. Okay, understood? You will write dx by dt. So you already got dx by dt, that is 0.3. So dy by dt will be 1.6 times dx by dt. Dx by dt is 0.3, and this 2.4 will go to here. Ready? Or you can write it like dy by dt is equal to 16 by 24 into 0.3. It's 2 by 3 times 0.3, or 2 times 3 by 30. So it will be 6 by 30, or easily you can do like this calculation. Straight away from 0.3 cancel is, you will get 10. So you will get 2 by 10. So every values is decimal values are given here. So you can write 0.2 centimeter per, sorry, it's meter per second in this question, right? Everything is on meter per second. So 0.2 meter per second. So what is this dy by dt? Listen, y is this. So change in y means the length of the shadow. The y is what? The length of the shadow. So rate the shadow is lengthening. The rate the shadow is lengthening is dy by dt, that is 0.2. We didn't get this answer. What is this answer? At what rate is tip of his shadow is moving? Tip of his shadow. Listen, what is 0.3 meter per second? The speed of this point. He is moving in this way. That means change in x. So the tip of the shadow is really on, if we move like this, the shadow is also moving. So x is changing, y is also changing. Or we can simply say the tip is at the distance x plus y from the lamp post or from the street light. The tip is at the distance x and y together. Ready? So otherwise we can write it like the tip is at x plus y, isn't it? The tip of the shadow is at x plus y. We can simply say that. So what they ask for, rate of change of the tip is moving. That means dt by dt, or d tip by dt. So we are going to differentiate this in the equation with respect to t. So you have to write dx by dt plus dy by dt when you're differentiating it. Ready? So the answer will be dx by dt plus dy by dt. What is dx by dt? It's 0.3. What is dy by dt? It's 0.2. So the final answer is what? 0.5 meter per second. That is the tip is changing its or the tip is moving at the rate 0.5 meter per second, and the length of the shadow is changing at the rate 0.2 meter per second. So you may get the confusion, both are same, sir. No, both are not same. Dy by dt means the length is only changing, but when he moves, suppose he is here and definitely the shadow is, the tip is at here, isn't it? So this length is not calculated. This is considered as what? Total x here, and from here to here we consider it as what? Y. So y and x together only we can say where the tip is. Okay, y only, if we are only considering y, what does that means? The length of the shadow. If you are considering x and y together, what does that means? The tip is at where? Okay, so this is the rate at which the tip is moving. This is the rate of change of length when the man is moving. Okay, so we can move into the next question. Listen, this one is the easiest question you can expect from the part rate of change of quantities, and it's not rely on dt also. So you can read this question. The total cost C of x associated with the production of x units of an item is given by C of x is equal to this. So they have given C of x. C of x is equal to 0.005 x cube minus 0.02 x square plus 30x plus 5,000. So this is the cost for producing x unit of item. If you put 3, you will get what? 3 units of the cost for 3 units of item. And if you put 10, you will get the cost of production for 10 units. Okay, then find the marginal cost. So this word marginal cost. So I'll explain what is marginal cost. MC, marginal cost, is equal to derivative of cost. Derivative of cost is what? Marginal cost. And marginal revenue means what? You may get another question like marginal revenue. So derivative of equation of revenue. So the equation of revenue and the equation of margin, equation of cost, they will give you in x. So you only need to differentiate with respect to x. So I'm going to differentiate it. I'll write c dash of x. C dash of x is what? Marginal cost. What is the derivative of it? I take the constant out, 0.005, and derivative of x cube is what? 3x square, minus, I take the constant out, 0.02, and derivative of x square is what? 2x, and derivative of 30x is what? 30, and derivative of 5,000 is a constant, it is 0. So when you multiply it, what you will get? 0.015 x square minus 0.04 x plus 30. And they need the marginal cost when 3 units are produced. That means the value of x is given. X is what? 3. So put x as 3 here. So marginal cost when the value of x is 3. So we can replace all these x with what? 3. So you will get 0.015 into 3 square, that's 9. 0.004 into 3 plus 30. So it will be, when you multiply it with 9, you will get 135 minus 0.12 plus 30. And when we calculate this, what you will get? 0.135 minus 12, you will get 113 minus 12, it will be only 0.015 plus 30, so it will be 30.015. That is the marginal cost when 3 units are produced. Easiest question here that you can expect from the part rate of change of quantities. So maybe they will ask for marginal revenue also. So listen very carefully. What are the 3 questions that we have done right now? One is like this. They will give you one situation, so you have to build one equation based on that situation. This is the equation that will for this situation. Then differentiate. They will already give you what? One value dy by dt. Substitute it, and you have to find another rate of change, that is dx by dt. They give dy by dt, you need to find dx by dt. And the second type question is also like they have given one situation, and you have to understand what they ask for. The tip is at x plus y. Listen, the tip is at x plus y, but the length of the shadow is what? Y. That is a catch from this question. And marginal cost and margin revenue, easiest thing, just differentiate, put the value, that's it. Okay, now these kind of questions only you need to expect from rate of change of quantities. The next part is increasing and decreasing functions. Increasing and decreasing functions. So before moving to the question, you have to know what is an increasing and decreasing function. I'm simply explaining it. Listen here. If a function is like this, it starts from A, it ends at B, in between there is C, so you can see this function is going upwards in this direction. So we can say it's increasing. And this part you can see the graph is coming down, so we can say it's decreasing. Listen very carefully. So I think you heard strictly increasing and strictly decreasing also. I'll explain that also here. Before that, if a derivative of a function is greater than 0, we say it is strictly increasing. Or if a function is less than 0, we can say it's strictly decreasing. So listen, if a function, the derivative of the function is equal to 0, we say it is critical point. The graphical representation is there here. If the function is increasing, all these points f dash of x will be greater than 0. All these points f dash of x will be less than 0. It going up, increasing, and reaches at a saturation point. At that point, f dash of x will be 0. Ready? At that point, f dash of x will be 0. The behavior of the function is changing from increasing to decreasing at the critical point. But sometimes the graph may go like this. Here reaches at the critical point and again increasing. It's increasing. So this type of critical point we called point of inflection. So at the critical point, 2 things can have happened. One thing is what? Increasing is changed into decreasing, or we can say decreasing is changed into increasing. First decreases, then increases at the critical point. So at the critical point, increases to decreasing may occur, or decreasing to increasing may occur. Or other option is what? Increases and increasing at the critical point. At that point we called it is point of inflection. Also the other thing also possible, it's decreasing from left side and again decreasing to the right side. Decreasing and again decreasing at the critical point. This critical point also we called what? Point of inflection. So listen, in this topic we have to know if f dash of x is greater than 0, is strictly increasing. If f dash of x is less than 0, strictly decreasing. If f dash of x is equal to 0, critical point. So you have to know what is critical point. At critical point, increasing and decreasing will change. The behavior of the function will change. So let's use these ideas to this question. You will get more clarity while we are doing the question. Listen. So I'm just writing f dash of x equal to, f dash of x is greater than 0, it is strictly increasing. F dash of x is less than 0, strictly decreasing. F dash of x equal to 0, critical point. Just write this here. Most of the question is only need this part. If the question is a little bit of complicated, then only you need the point of inflection and all other things. So listen, the real function f of x equal to this, they have given a function, then strictly increasing in this interval, they have given more options. So I'm going to find at which interval this function is increasing and decreasing. What does that mean? Listen, if a function is like this, this is A, this is B, this is C, this is D, this is E, this is F, this is G. Listen, at this interval A to B, it's increasing. At B to C, it's decreasing. At C to D, it's increasing. At D to E, it's again decreasing. E to F, it's increasing. And F to G, it's decreasing. So considering a specific interval, it's increasing. Considering another specific interval, that is from B to C, it's decreasing. C to D, this interval, it's increasing. You can see that, isn't it? So this function is also maybe going like this. So we need to find from where to where it's increasing, from where to where it's decreasing. But it's very easy if you know differentiation. Ready? So let's do it. So first of all, we need to differentiate this f dash of x. If you want these intervals, you have to differentiate first. The first step is what? Differentiate it. When you're differentiating, what you will get? 6x square minus 6x minus 36. And next part is what? We need to find the critical point. Why we need critical point? At critical point, you can see here, listen. This is a critical point. Increasing to decreasing. The change is happening at critical point. Here also, this is critical point, this is critical point, this is critical point. So actually, the changes only happens at critical points. So first we will find critical point and we will check the left and right of critical point to check whether the function is increasing or not. So listen very carefully. We need critical point. Where you will get critical point? At where f dash of x is equal to 0. So f dash of x equal to 0. F dash of x equal to 0 at critical point. And what is your f dash of x? 6x square minus 6x minus 36 is equal to 0. So if I take this 6 out, if I take this 6 out, what I'll get? X square minus x minus 6 is equal to 0. If I take the 6 to this side, it will be x square minus x minus 6 is equal to 0. I have to solve this one. So listen, the difference between two numbers is minus 1 and multiply that together, you have to get minus 6. What are the numbers? When you multiply 2 and 3, you will get 6. So if this is negative 3, if you multiply 2 and negative 3, what you will get? 2 and negative 3, you will get what? Minus 6, and minus 3 plus 2 is what? Minus 1. So we have to invert the sign. So you will get the solution as minus 2 and 3. So it's like you can use quadratic formula also to solve this. I'm just directly doing it because we all know how to solve that. So x is equal to minus 2 and 3. So you have two critical points. So minus infinity to infinity is the real numbers, all the real numbers in between minus 2 and 3. So we have 1, 2, 3 intervals. Now we need to identify what is happening in these intervals. So how do we find that. If f dash of x is greater than 0 in an interval, it's increasing. If f dash of x is less than 0 in an interval, it's strictly decreasing. So who is f dash of x? Here we have the f dash of x, 6x square minus 6x minus 36. So f dash of a number between minus infinity to minus 2, I'm taking as minus 3. When you're putting minus 3 in this derivative, what you will get? 6 into 9 minus 3 square is 9. Minus 6 into minus 3 is plus 18 and minus 36. Of course, it's like 54 plus 18 minus 36 is positive. We don't need the exact value. We only need what? It's greater than 0. F dash of minus 3 is greater than 0. That means you took a number between this and you got the derivative is greater than 0 for that. That means if the derivative is greater than 0 for that, it's increasing. So we can conclude that strictly increasing in the interval minus infinity to minus 2. Minus 2 is not included. Minus 2 is a critical point. So it's strictly increasing from minus infinity to minus 2. If they didn't ask for strictly increasing or strictly increasing, just ask for what? Increasing or decreasing only, you can include what? Minus 2. You can include the critical point for just increasing and just decreasing. You're not allowed to include the critical points if they ask for strictly increasing and strictly decreasing. That is the difference between strictly increasing, strictly decreasing, and increasing and just increasing and decreasing. So what is your next interval? Minus 2 to 3. There is a 0 in between that. I'm going to put 0 in it. The derivative, this term becomes 0, this term becomes 0. You will get minus 36. It's less than 0. The derivative is less than 0 when we put a value in between that, in between these two critical points. So if it is less than 0, it's strictly decreasing. So it's less than 0, strictly decreasing in the interval minus 2 to 3. Third one here, I'm going to put 4 because between 3 and infinity we have what? 4. So f dash of 4 will be 6 into 16 minus 6 into 4 minus 36. Of course, it's greater than 0. It's greater than 0. So strictly increasing in the interval 3 to infinity. So we got the intervals. First interval increasing, second interval decreasing, third interval increasing, decreasing, increasing. So now let's look into the options. Strictly increasing in minus infinity to minus 2. Yeah, it's fine. Strictly decreasing in minus 2. No, it's minus 2 to infinity is not allowed. Only minus 2 to 3. If it is till 3, it's fine, but it is infinity. So option A is not there. Strictly decreases from minus 2 to 3. Yeah, of course, yes. Minus 2 to 3, it's decreasing. It's fine. So let's check into others also. Other options also. Strictly decreases from minus infinity to 3. Minus infinity to 3, yeah, it's increasing and decreasing is there, so it's not allowed. So strictly decreasing in minus infinity to minus 2, no, minus infinity to minus 2, it's increasing. So only this option, option B, is the correct one. Ready? So we can move into the next type of question. Listen. This question is inequality type question. At the beginning we said we have two types of question that you can expect from increasing and decreasing part, and the first one is what? Interval type. So we identify this interval is increasing, this interval is decreasing, and this interval is what? Increasing. Before that we found intervals by finding critical points. So this question is all based on intervals, but the next question is from the same topic, increasing and decreasing, but not using intervals. We are going to use inequalities. So what is the difference between the question? Just listen. The value of b for which the function, they have given a function here, is strictly decreasing over r. So they asked for at what value of x, this function is strictly decreasing. That means they asked for what value of x, f dash of x is less than 0. You know that strictly decreasing when f dash of x is less than 0. So they ask for what value of x, f dash of x. The derivative of this function is less than 0. At what value of x, the derivative of this function is less than 0. So we can find the derivative, right? What is f dash of x? Derivative of x is what? 1, and derivative of cos x is what? Minus sin x, and derivative of b is what? 0. You don't need to write. So the interval they ask for is the interval where f dash of x is less than 0. F dash of x is this, so we have to write like 1 minus sin x is less than 0. At that value of x, this inequality will satisfy. I think you understood how did I get this inequality, because they ask for decreasing only if the f dash of x is less than 0, f dash of x is 1 minus sin x, so 1 minus sin x is less than 0. So I'm going to take this sin x to that side, 1 is less than sin x. Ready? So 1 is less than sin x, and sin x should be greater than 1. The value of sin x is between what? The domain and range of sin x. You have to know that, domain and range. The domain is any real number. You can put any real number for the sign, but the value will lies between -1 to 1. And in this condition, they said 1 is less and sin x is bigger than 1. What does that mean? Sin x can't bigger than what? 1. This inequality is not acceptable. It is not acceptable. So this inequality is not acceptable means, therefore f dash of x will not become less than 0. Not become less than 0. Not become less than 0. It's not become less than 0. What does that mean? You will, whatever the value you are putting for b, f dash of x will not become less than 0. So no values of b exist. Whatever the value you are putting here, that won't affect, that won't correct this inequality, because b doesn't have any involvement here. When you differentiated, the b is gone. If you change the b with any number, any real number, when you're differentiating, it will gone, and this inequality will not happen, because sin x is not bigger than 1. Sin x is between -1 to 1. So you have to understand inequality a little bit to answer this kind of question. Easily you can answer. I hope you understood. So no value of b will save this function. No value of b will make this function strictly decreasing, because b doesn't have any involvement in this inequality, of course. So next question. Next question is also the function x minus sin x is decreases for. So it's again what? Inequality question. Decreases, right? They didn't ask for what? Strictly decreases. They just asked for what? Decreases. Anyway, just answer it. What is f of x here? The f of x, they have given x minus sin x, and derivative of it is what? F dash of x is equal to 1 minus cos x, and it decreases when f dash of x is less than 0. If less than 0 means strictly decreases. F dash of x is less than or equal to 0 means just decreases. Remember, it can be equal to 0. They ask for only what? Decreases. In the options, I am not able to see any equal to sign. Let's see what we are getting. So f dash of x is what? 1 minus cos x is less than or equal to 0. So 1 less than or equal to cos x. 1 less than or equal to cos x. Ready? So again, this cos x is between -1 to 1. This cos x is between -1 to 1. Cos x will not become greater than 1. So greater than 1 option is not there. So it can become equal to 1 for what? The value 0. So there is no, this is not, it's not just 0, it's also pi by 4 is not, pi by 4 is between 0 and pi by 4, and it's not included 0. So I'm not taking that. Less than pi by 2, I'm not taking that, because we need value that is greater than 0. No values will be there, not all value. No value of x. No value of x, it will, I think this question is strictly decreasing, So the value of cos x is between -1 to 1. You will not get any value that is more than what? 1 for cos x. So 1 less than or equal to cos x is impossible inequality. It's an impossible inequality. So this inequality will not exist. Therefore f dash of x will not become less than 0. If f dash of x become less than 0, then only you will get a decreasing function. So it's not possible. For any value of x, this function will not become decreased. It will be any other case. Okay. So in increasing and decreasing part, you have two kind of question you can expect. That is one relay on what? Inequality, one relay on what? Intervals. and other part is like this using inequalities. Ready? So next, one more question. Find the interval. So this is an interval question. Find the interval in which the function f given by f of x equal to that. So it between 0 and pi by 2, and 0 and pi by 2 is not included. So this function is from 0 to pi by 2, and 0 and pi by 2 is not included. It's not included. So we need to find the intervals. So yeah, of course we have to differentiate. F dash of x is what? Sec square x minus 4. Okay, then we need the critical point. F dash of x equal to 0 at the critical point. That means sec square x minus 4 is equal to 0. That means sec square is equal to 4. So sec x can become plus or minus 2. If it's plus 2, you'll get 4. If it's minus 2, you'll get 4. But you only allowed to take first quadrant, right? In the first quadrant, you only get what? Positive number. So you only write sec x is equal to 2. If the second quadrant also included, if it is from 0 to pi, you should have considered what? Minus 2 also, because sec is negative in the second quadrant. So at what value of x you are getting 2 for sec? It will be pi by 3. So you got your critical point, that is pi by 3. Pi by 3, that is 60. So in between, this is the first interval, this is your second interval. In the first interval, I am going to take a one point, that is pi by 6. Ready? And I am going to put that in the derivative, f dash of pi by 6. What is your f dash of x? This is your f dash of x. That is sec square pi by 6 minus 4. What is pi? Sec pi by 6. It's 2 by root 3. It's 2 by root 3. The whole square minus 4. 4 by 3 minus 4. Taking 4 out, 1 by 3. It's negative. 1 by 3 minus 1 is what? Negative. You don't need the value exactly. It's literally, you can identify that from here onwards. You can see this value is negative. So f dash of pi by 6 is less than 0. Therefore, f dash of x is less than 0. Less than 0 means strictly decreasing. Therefore, strictly decreasing in the interval 0 to pi by 3. 0 to pi by 3. So it's decreasing in this interval. Ready? So decreasing on the interval what? 0 to pi by 3. Now we need increasing interval. Usually this will be the increasing interval, but there is a chance at the second interval also it's decreasing. Then the critical point become what? Point of inflection. That's a possibility. So we have to check that also. But the problem is you are not able to find any known value that can put between pi by 3 and pi by 2. Ready? So at that moment what we will do is we'll just try like this. We need what? We have to check it is increasing or not. So we have to do what? F dash of x is greater than 0. We use inequality also here because we don't have any value to directly put in the derivative. So we consider f dash of x is greater than 0 and we will find at what value of x it will become greater than 0. So f dash of x equal to greater than 0 means what? Sec square x minus 4 is greater than 0. So sec square x is greater than 4. Ready? So sec x can become greater than 2 or sec x can become less than minus 2. Two possibilities. When sec x is getting greater than 2, you will get, listen, what is the value of sec here? You know sec is starting from sec 0, sec 0, sec pi by 6, sec pi by 4, sec pi by 3, sec 90. Ready? Sec 0 is what? It's not defined. Sorry. Sec 0 is what? 1. And sec pi by 6 is what? We know 2 by root 3. Sec pi by 4 is what? Root 2 and 2. And again, it's going to become what? Not defined. So actually, the value of sec is increasing 1 to 2 to and infinity. It's going to infinity. So it's increasing. So till here, these values are below 2. These values are below 2. So from 0 to pi by 3, the value of sec is less than 2. It only increases from pi by 2 to pi by 3 to pi by 2. So the value of sec x is greater than 2 when x is greater than pi by 3 and between pi by 2. So at this interval is satisfying. So here it is increasing. We used inequality also here because we are not able to put any value. So otherwise you have to identify this between the value of sec is increasing from 0 to pi by 2 from the graph or from the table. So definitely pi by 3 to pi by 2 it's increasing. You can think like that also. So the increasing interval is what? Pi by 3 to pi by 2. It's pi by 3 to pi by 2. Listen, here we don't have a direct value to put like pi by 6. After pi by 3 we only know pi by 2. So what we have done, we took f dash of x equal to greater than 0. We made what? One inequality. F dash of x is e square x minus 4. So I took the minus 4 here. So we have two options. We only need to consider the positive option because here only positive values in the first interval 0 to pi by 2, first quadrant 0 to pi by 2. So we know that when you put more than pi by 3, at that time only you are getting value for sec that is greater than 2. So from pi by 3 to pi by 2 only you are getting sec x is greater than 2. So at that point only, at that interval only, f dash of x is greater than 0. So your increasing interval is pi by 3 to pi by 2. Ready? So these kind of questions only you need to expect from our increasing and decreasing part. Okay. So now this part is the most important part. You need to study in this chapter. You can expect very big number of marks from here, this topic. Okay. So this part is called maxima and minima. So in this part we have what? One at the beginning I showed you this maxima and minima. We have 4 types of question we can expect. What are the 4 types of question? Direct application question and 2 variable to 1 variable question. So they will give you 2 variable. We have to convert that back into 1 variable function to perform the differentiation, and they will give you word problems. They will give you some situation. We need to build function from it and show that, prove that, or find type question. That's also related to what the word problem, but we need to prove something. Prove some radius is equal to something like height by 2, or height is equal to 2 times radius, like that kind of question you can expect. So all these 4 types of question we are going to discuss here. So come on. So this is the first question from maxima and minima. So this question is a direct question. I have listed 4 types. You know what is the 4 types. And the first type is what? Direct question. So this is a direct question. The value of x for which x minus x square is maximum. So we need to find the value of x where this function is maximum. So they have given the function directly. They have given f of x equal to x minus x square. So if you need to find the maximum, we have second derivative test. What is second derivative test? F double dash of x is greater than 0 means f is minimum, and f double dash of x is less than 0 means what? F is maximum, and f double dash of x is equal to 0 means what? Second derivative test fails. So second derivative test is this. And what is first derivative test? I always prefer you to go for second derivative test first. Then if it fails only, you need to go for what? First derivative test. What is first derivative test? First derivative test means if you find the critical point, if this is A and this is B and this is C, ready, and this is D, okay, so this is a critical point D. At the left side, f dash of x is what? Greater than 0. At the left side, f dash of x is what? Less than 0, increasing and decreasing. So maximum will be there. Left is increasing, right is decreasing. At the critical point, at that critical point is what? Maximum. And if the left is decreasing, right is increasing, f dash of x is greater than at the right side. At the left side, f dash of x is what? Less than 0. So this point is what? Minimum. Local minima. This is what? Local maxima, and this is what? Local minima. The maximum values and minimum values that occur at the critical point is called the local maxima and local minima. Ready? So we can do second derivative test here. Let's check. So when you differentiate first, f dash of x will be 1 minus 2x. 1 minus 2x. We need critical point. So what is your critical point? Where will you get critical point? F dash of x equal to 0. Ready? That is 1 minus 2x is equal to 0. So 1 is equal to 2x, x equal to 1 by 2. So there is only one and only one critical point. Then we go for the second derivative test. What is f double dash of x? Derivative of this is what? Minus 2. So in this equation, in this second derivative, there is no x. So we can simply write f double dash of whatever the critical point, you only get negative 2, which is less than 0. Less than 0 means what? If f double dash of x is less than 0 means what? It's maximum. Ready? So it's maximum at where? 1 by 2. So the value of x for which x minus x square is maximum is what? 1 by 2. So your answer is what? 1 by 2. So this x is what? Critical point, or you can see f dash of c. You can write it what? F dash of c. You are going to put critical point in the second derivative. Why we are putting critical point in the second derivative? Because maxima and minima will only occur at where? Critical points. Here also left is increasing, right is decreasing. So the critical point is maximum. Left is decreasing, right is increasing. The critical point is what? Minimum. So critical point is the one becoming maximum and minimum. So local maxima and minima, what is the difference between local maxima and local minima? Local maxima and local minima is occur only at critical points. And absolute maxima and absolute minima is there that can occur at the critical point as well as the end points. But local maxima and local minima will not occur at where? End points, only at the critical point. I will explain more in upcoming questions. So the next question is what? Find the minimum value of this function. So function is given f of x is equal to ax plus by. I'm not calling it f of x, I'm just calling it f, this function f. If I call it f of x, the function should be in terms of x. Here x and y is there, I'm just calling f. The function f is given by ax plus by. Also, they have given one hint, that is xy is equal to c square. Xy is equal to c square. So here you have two variables. So this one is two variable to one variable form. Last one, the function is only having, where's the function? Function is only having one variable, that is x. But in this question, you have two variables. If you have two variables, you have to convert that back into one variable function. That's why they have given this hint. If the function is two variable, definitely there will be a hint that will help you to change this two variable function into one variable function. So here you can find y is equal to what? C square by x. So your function will become ax. Instead of y, you can replace c square by x. Now I can call this function f of x. That is the first step. if you're maximizing or minimizing, you're going to find local maxima or local minima for any function. That function should be in single variable. All the upcoming questions, we are going to make the function a single variable function with the hint that they have given in the question. So listen. So if you got the function in single variable, the first step is what? Find the derivative, find the critical point, go for the second derivative. So first derivative, what is derivative of ax? It's a. I'm taking the c square constant out, and derivative of 1 by x is what? Minus 1 by x square. This is the derivative, first derivative. And what is where you will get the critical point? F dash of x equal to 0. This is where you are getting critical point. What is your f dash of x? It's a minus c square by x square is equal to 0. So you will get a is equal to c square by x square. So x square is equal to c square by a. So x is equal to plus or minus c by root a. Plus or minus c by root a. You have two critical points. Out of these, we need to find which one is minimum. So we go for the second derivative test. We have to differentiate this again. So f double dash of x, derivative of a is a constant, minus c square is a constant, and derivative of 1 by x square. Listen, when I differentiate 1 by x, I'll get what? Minus 1 by x square. When I differentiate 1 by x raised to n, I consider this x raised to n as x, so I'll get minus 1 by x raised to n the whole square. But I have to differentiate this x raised to n, the one who replaced x. Here, instead of x, who replaced it? X raised to n replaced it. We have to apply chain rule there. I differentiate it like that. So when you're differentiating 1 by x square, you will get minus 1 by x square the whole square into the one who replaced x is what? X square. So I multiplied 2x. So you will get what? This negative and this negative become positive c square, 2c square x. 2c square x. All divided by x raised to 4. Cancel these two. You will get what? 2c square by x raised to 3 as your f double dash of x. Now what? If you got the second derivative, you can put the critical point in the second derivative and check it's greater than 0 or less than 0. Okay, I will go. We have two critical points, that is x is equal to plus c by root a or minus c by root a. So I'm going to put the first one, c by root a is equal to 2c square by c by root a the whole cube. Listen, nothing negative is here. It's every term is positive, so it's greater than 0. Therefore, f double dash of c, f double dash of critical point is greater than 0. Therefore, f is having minimum or local minima. F is having local minima at x equal to c by root a. At x equal to c by root a. Find the minimum value of this function where x into y is equal to c square. They ask for the value also. So listen, so x is equal to c by root 2. This is the point at where you are getting the maximum value. The minimum value. So listen, c by root a is the point. So this is your function f of, in terms of x we have f of x equal to x plus c square by x. So f of x equal to ax plus c square by x. Ax plus c square by x. Your critical point is x is equal to c by root a. At this point you have minimum, so the minimum value will be, when you are putting that minimum point, you will get the minimum value. So a times c by root a plus c square by c by root a. So it will be cancelled, you will get root a. So, and these two will be cancelled, you will get root ac plus this root a go to the numerator, you will get root ac, you will get 2 times root ac. This is the minimum value that can get from this function. Whatever the x you are putting, this is the minimum that you can get. Okay, so now we can move into the next question. Listen, what is it? So we have done direct question, we have done 2 variable to 1 variable conversion question. Now the third type of question for maxima and minima is what? Word problem. So they will give you one situation, we have to build the function from it. Last question, you go they directly give you the function f of x equal to, or f is equal to ax plus by. So but we have to convert that into single variable, and the question before that they directly given the function f of x equal to x minus x square. So but here there is no trace of function but some situation. Sum of two numbers is 5. Let's say x plus 5, x plus y is equal to 5. If the sum of the cubes of these numbers is least, that means sum of the cubes of these numbers, that's what we need to minimize. Least means minimize. This is what we need to check whether it is minimum or maximum. Okay, then find the sum of the square of these numbers. So you need to find what? Find what? Find x square plus y square. So this is the question. These are the given things. Given what? X plus y is equal to 5. X plus y is equal to 5. Why they have given this? This is the hint. This is the hint. What hint? Listen. What is your function? F is equal to x cube plus y cube. This is what you need to minimize. So minimum or maximum, whatever you need to find, this is the function. That's what the question says. But this is 2 variable function. That's why I just called it f. It's not just f of x because x and y is there. So this x plus y is equal to 5 is given for y is equal to what? 5 minus x. So now you can replace this y with what? 5 minus x. So it will be x cube plus, I replace this y with what? 5 minus x. It will be 5 minus x the whole cube. That is your f of x. Now I can call it f of x because this function is in terms of x. It's a single variable function. The 2 variable is converted into single variable function. They didn't give you any function here, but we created a function x cube plus y cube as your function, and that is also 2 variable function, and they gave you one hint. From that hint we make what? The single variable function. Now go for the critical point, second derivative, find maximum or minimum. Listen and listen. F dash of x is what? 3x square plus 3 times 5 minus x the whole square, and its chain rule. Derivative of 5 minus x is minus 1. So your f dash of x is what? 3x square minus 3 times 5 minus x the whole square. So critical point at f dash of x equal to 0, critical point. Easy. So it will be 3x square minus 3 times 5 minus x the whole square is equal to 0. I'm going to take this negative part to that side. You will get 3x square is equal to 3 times 5 minus x the whole square. 3 cancel. Then x equal to 5 minus x is your option. So 2x is equal to 5 is your option, and x is equal to 5 by 2. That is your critical point. We need to check this critical point is giving what? Least. That means minimum or not. For that we have to do the second derivative, f double dash of x. What is f double dash of x? This is your f dash of x. It will be 6x minus 6 times 5 minus x, and derivative of 5 minus x is minus 1. It will become plus. So I'm going to put your critical point in it. Second derivative 5 by 2. It will become 6 into 5 by 2 plus 6 into 5 minus 5 by 2. What is 5 minus 5 by 2? It's 5 by 2. So it's 2 times 6 into 5 by 2. It's definitely greater than 0. F double dash of 5 by 2 is greater than 0. Therefore f is having local minima at x equal to 5 by 2. At x equal to 5 by 2 you are getting the least value for the cubes of the sum of cubes of these two numbers. And what they need to find x square plus y square. You got what? X equal to 5 by 2. So y is what? 5 minus 5 by 2. Remove half from 5. Sorry, half of 5 from 5. You get what? 5 by 2. Y also 5 by 2. X and y, you got to x and y. That satisfies this condition. What condition? The sum of cube of these two numbers is minimum. Then what they need to find? X square plus y square. It's 5 by 2 the whole square plus 5 by 2 the whole square. It's 25 by 4 plus 25 by 4. It's 50 by 4. It's 25 by 2. That's the value for x square plus y square. So this question is have word problem, and we build a function from it, and that function is two variable. From the hint we converted that into single variable. Critical point, second derivative, put the critical point greater than 0, therefore f is minimum. We got x for the minimum, and we got 5 y from it, x and y we put in this, we answer the find the question. Okay, so we can move into a little more complicated question. So the next question is they have given the function, okay, but the area of the trapezium, we need to find the area of the trapezium defined by function. This is the given by this function. So the area of the trapezium is given f of x equal to 10 plus x into root of 10 minus x square. Then the area when it is maximum, we need to find the area. Area means f of, this is the equation of area, we need to find the x, that is when the area is maximum, then we put that here. So function is given, it's a direct question. So the function is single variable also, it's not that much complicated, but this question is have a slight change. They may give you 3 sides of the trapezium is 10 centimeters other than the parallel sides, and we need to maximize the area of this one. So they will not give you the function, they will give you the situation. These 3 sides of the trapezium is equal to 10 centimeters, and we need to maximize the area. So first of all, what is the area of a trapezium? What is the area of the trapezium? Half sum of parallel sides into height. So this is h, this length we don't know, x, this length we know that is 10 because it is 10. So from this we will get half of sum of the parallel sides. These are the parallel sides. So this is x plus x, 2x plus 10, 2x plus 10. This is one side, and other parallel side is 10 plus 10, and height is what, this one, it will be root of hypotenuse square minus x square. You will get this. So area will be equal to 1 by 2. I'm taking 2 out of this, this is 20, I'm taking 2 out of it. You will get x plus 10 into root of 10 square minus x square. So these two will be cancelled. 10 plus x into root of 10 square minus x square. You can see that here, 10 plus x into root of 10 square minus x square. So they may give you the situation like 3 sides of the trapezium is 10 centimeters other than the parallel sides. Then you need to maximize the area, so you have to build the function for area. So in this question they have directly given. Okay, so anyway you need to maximize. This is your f of x, but you have to square this. When you square this both sides, what you will get? 10 plus x the whole square into 10 square minus x square. The square of this function, that is f of x the whole square, I am calling it g of x. Why did I square both sides? To remove the square root. With the square root the differentiation is little more difficult, and if the square root function is increasing and the square function is also increasing, so you don't need to confuse it with the square root. If you get a square root in the question of maxima and minima, just remove it by squaring it. So instead of checking the maximum value of f of x, now I need only to check the maximum value of g of x. Both are area function. This is area function and this is area. This is area function and this is area. So g dash of x, I want to do product rule. This is first function and this is second function. So first function into derivative of second function, it's minus 2x plus second function, that is 10 square minus x square, into derivative of this is like x square form. So 2 times 10 plus x, but it is not x, it's 10 plus x, and derivative of 10 plus x is 1. So you don't need to multiply it there. So g dash of x is equal to what? 10 plus x the whole square minus 2x into 10 plus x the whole square plus 2 times 10 plus x into 10 square minus x square. So this is your derivative where you will get the critical point at where g dash of x is equal to 0. That means minus 2x into 10 plus x plus 2 times 10 plus x into 10 square minus x square is equal to 0. I'm going to take this part to that side and I'll keep this part to this side. So it will be like 2 times 10 plus x into 10 square minus x square. It can be written as a minus b into a plus b. So 10 minus x into 10 plus x, and this negative 2x into 10 plus x the whole square goes to that side. 2 times x into 10 plus x the whole square. This 10 plus x into 10 plus x become 10 plus x the whole square, and this will be cancelled and these 2's will be cancelled. Then finally what you will get, 10 minus x is equal to x. 10 minus x equal to x. So 10 is equal to 2x, so your x will be 5. So your x equal to 5, and you need to find second derivative to check it is maximized or it's check whether the critical point that you got is maximum or minimum. So maybe it's minimum. So then if it is minimum, you have to conclude that there is no maximum area. Okay, so let's check its maximum or minimum by doing the second derivative. So what's the first derivative? First derivative is this one. Okay, it's 2 times 10 square minus x square into 10 plus x minus 2x into 10 plus x the whole square. 2 times 10 square minus x square into 10 plus x minus 2x into 10 plus x the whole square. We need to differentiate this again. So f double dash of x will be, take the constant out, again do the product rule here. First function into derivative of second function is 1 plus second function okay, you only have to do this into minus 2x. Okay, and take the constant out, and this is x is your first function, this is your second function. First function into derivative of this will be 2 times 10 plus x plus second function 10 plus x the whole square into derivative of x is 1, and you have to put the critical point in it. So 2 times 100 minus 25 plus, it's minus when you multiply with minus 2 into 5 into 10 plus 5, it's 15, close the bracket, minus 2 into 5 because x is 5, 10 into 15 plus 10 plus 5, 15 the whole square. Ready? So it will be 2 times 75 minus 10 into 15 is 150 minus 2 into, if I take 15 out of it, I have to write 10 plus 15, then it will be minus 75 into 2, it will be minus 150 minus 30 into 150. Ready? It's negative, of course, both are negative. It's less than 0, therefore f is maximum at x equal to 5. And they ask for what? The area also. Then the area when it is maximum, we need to find the area also. They have given the area function, you just need to put that in it. So what you will get, just put just find f of 5. This is area function, 10 plus 5 into root of 100 minus 5 square, that is 25. It will be 15 root 75. It will be 15 root 25 into 3. It's 15 into 5 root 3. It will be 75 root 3 centimeter square. That is the maximum area that this trapezium can have. Okay, let's move into the next question. Next question. A wire of length 20 centimeter, there is a wire with length 20 centimeter, is bent in the form of a sector of a circle. So this is sector of a circle that we bent this into make that, and this will be the radius, ready, and this will be the angle, and this will be the arc length. Okay, the maximum area that can be enclosed by the wire. So we need to find an equation. We need to find an equation for the area of this sector. What is the area of this sector? Area of this sector will be, what is the area of the total circle? It's pi r square. And the total angle is 2 pi. Out of that 2 pi angle, we only have theta. We only have what? Theta. So we have to multiply theta by 2 pi. So pi r square into theta by 2 pi will be the area of this sector with the angle theta. So how to get the angle theta? You have to know theta is equal to L by R, arc length into radius. So just keep it there, and they said the total length of the perimeter of this sector is 20 centimeter, because the length of this wire is 20 centimeter. We bend that to create this sector. So that means this r plus this r plus this L, that is 2r plus this L is equal to what? 20. So L will be equal to what? 20 minus 2r. Okay, then theta will be what? 20 minus 2r by r. Ready? So you got what? Theta here. You got theta. What is theta? 20 minus 2r by r. So these two pi's is cancelled off. Then now you have two variables. Listen, pi square and theta. So we got theta from this. That's why all the questions from this segment is like this. They will give you a two variable, or we need to create a two variable function. Or otherwise, if the situation, when you evaluate the situation, you will get a two variable function, and they will give you some information to convert this two variable function into a single variable function. So r square by 2 into theta. What is theta? It's 20 minus 2r by r, and I take the 2 out, so I'll get r square by 2. I can call it a of r right now because only r is the variable there. So this r square and r is gone. Then I take the 2 out, I'll get 10 minus r. Ready? This is gone. Then these two will be cancelled. Then a of r, the simplified version of a of r will be 10r minus r square. So now you got what? A area function that is only have one variable. So now differentiate it. A dash of r. What is a dash of r? It's 10 minus 2r. At the critical point is where a dash of r is equal to 0. So 10 minus 2r is equal to what? 0. 10 is equal to 2r. R is equal to what? 5. You got r is equal to 5. So r is 5. We need to check it is maximum or not. Area is maximum or not. So a double dash of r, what is it? It's minus 2. Whatever the r you are putting, you only get minus 2, which is less than 0. Therefore, max at r is equal to 5. Local maximum at r is equal to 5. Then we need to find the area, right? Then we have the equation for area is here. So a of 5 is equal to 10 into 5 minus 5 square, that is 25. That is 50 minus 25, it's 25. 25 centimeter square. Which option? Option B. Okay. So every question is the same pattern. They will give you some situation, create equation from the situation. Definitely in that equation, definitely there will be two variables. So there will some hint to convert that variable, this theta, in terms of r, replace it. Now you will get a function in terms of one variable, differentiate it, critical point, put it in the second derivative, check whether it is maximum or minimum, put back in the function equation that they asked for. Simple. Every question is same kind. You may feel like they are different, many kind of question is there, but every question is following the single pattern. So go for the next one. The question is, show that altitude of the right circular cone of maximum volume that can be inscribed in a sphere. So let me explain the question. There is a sphere, and inside it there is a right circular cone. So inside it there is a cone. This is the cone. Listen. Inscribed in a sphere, the right circular cone is inscribed in a sphere of radius r. So the radius of the sphere is what? R. Let's draw it like so. This is the diameter of the base of the cone, and this is the height of the cone, and somewhere here at the mid is the center of the sphere, and from the center to the sphere they have given that length is what? Radius, and I'm calling this length is h, and I'm calling that length as capital H, height of the cone, right circular cone, and radius of the right circular cone I'm calling it capital R, and radius of the sphere is what? Radius of the sphere is what? Small r. Ready? So show that the altitude of the right circular cone is 4r/3. So we need to show that. It's a show that question. Altitude of the right circular cone, that is h, from the figure it's capital H, it's 4r/3. What is the small r? It's radius of the sphere. And we have to know one thing, r is a constant. R is a constant because the sphere is given and you are carving out, or you are inscribing a cone inside it. So the height of the cone can be vary as per what kind of cone is you are inscribing it. And from that we have to understand this h and r, this capital H and capital R is variables. The sphere is given and this height you can reduce and the radius you can increase or decrease. You can get different shape of cones inside it, but the sphere is fixed. So you have to understand this h and r is variable and small letter r is a constant because that is the radius of the sphere and the sphere is given. This much information you have to understand. Also show that, we need to show that this, also show that after this we can go for this part. After doing this part, I'm reading the question again till here. Show that the altitude of the right circular cone of maximum volume. So we got one more information. We need to maximize volume. Volume is the one we need to maximize. So the cone's volume is maximum. We need the maximum volume. So what is the equation of the volume of the cone? It's 1/3 pi r square h, and here the r is capital R, height is capital H. You got an equation with the two variable. So if you want to maximize or minimize, you need an equation in one variable. So we have to convert that back into one variable equation. How do we do that? So they have given this. That's what we need to prove. Okay, so we have to find it from here. Listen very carefully. This length is h, ready, and this length is what? R, ready, and this length is also what? Small letter r, small letter r. So this length is what? This length is what? Capital H minus small letter r. So this length is capital H minus small letter r, this is capital R, this is small letter r. So from this triangle OAB, from OAB, from triangle OAB, using Pythagoras theorem, we can say that r square, capital R square, is equal to h minus small r the whole square plus capital R the whole square. From here I can create capital R square. So capital R square is what? Small r square minus capital H minus small r the whole square. So you got an equation of capital R square in terms of small r square, and small r square is constant and h is a variable. You can know that from it. So your equation of volume will be 1 by 3 pi, I call it pi by 3. Instead of this r square, I am writing r square minus pi minus r the whole square instead of this r square into h. Now see here, we have h here, h here. What is h? H is a variable. And what is these r's? These are constants because r is a constant. Now only one variable here, and we call it a, then we can call this function v of h. This function is in terms of h. Just simplify it, or you will get pi by 3 into r square minus h square plus r square minus 2 hr into h, while opening the bracket, r square minus h square minus r square plus 2 hr into h. It's gone. Open the bracket with h, you'll get v of h, the simplified form of v of h. It's pi by 3 times h into this 2h square r, or I can write 2r h square because 2 and r are constant, h only the variable, minus h cube. So this is the volume's equation in one variable. Okay, pi by 3 2r h square minus h cube. So volume of, in terms of h, pi by 3 2r h square minus h cube. So this is what we need to maximize. So differentiate it. It will be 4rh minus 3h square. This is where you get the critical point when it becomes 0. That means pi by 3 times 4rh minus 3h square is equal to 0. This constant goes to there, becomes 0. So 4rh is equal to minus 3h square goes to that side plus h square. These 2 is gone. You will get 4r by 3 as your h. Listen, this is the thing that you need to show, that h is equal to 4r by 3, h is equal to 4r by 3. We proved it, but we have to check its maximum or not by differentiating again. V double dash of h, pi by 3, 4r minus 6h. Ready? When you put h is equal to 4r by 3, definitely you will get it's less than 0. You can put it and check. Less than 0, therefore V is, volume is max if h is equal to 4r by 3. Hence we proved that. And that's what they asked you to show. So we shown that h is equal to 4r by 3 by doing this. Also show that the maximum volume of cone is 8 by 7 times of the volume of sphere. We need to show that volume of cone is 8 by 27 times of volume of sphere. Ready? Otherwise we need to show that volume of cone divided by volume of sphere is 8 by 27. So what is volume of cone by volume of sphere? Its volume of cone is 1 by 3 pi r square h, and volume of sphere is what? 4 by 3 pi r cube. Ready? So we have equation of volume of sphere, volume of the cone in terms of what? In terms of what? H. In terms of h, that is this one. Ready? So you can use that there. It's pi by 3 2rh square minus h cube. It's here. Pi by 3. This is volume of cone in terms of height. Pi by 3 2r h square minus h cube. And its volume of sphere is 4 by 3 pi r cube, isn't it? R is we know that 4r by 3 is equal to h. That's what we found. And r is what? 3h by 4. 3h by 4. So I replace this r with what? 3h by 4. The whole cube. So this is gone. This is gone. Then what? This r also need to replaced. So 2 times r is what? R is what? 3h by 4. 3h by 4 into h square minus h cube, all divided by 4 into 3 cube, h cube by 4 cube. So these two you will get 2 here, and this is gone. You will get 4 square. Rest I am going to do here. So this is h cube here. This is also h cube. I am going to take the h cube out. Volume of cone by volume of sphere is equal to, I am going to take the h cube out. While you are taking h cube out, you will get 3 by 2 here. 3 by 2 minus 1. 3 by 2 minus 1. And at the denominator you have 3 cube h cube by 4 square. By 4 square. So these two is gone. Ready? So again cross multiplied, what you will get? 3 minus 2 is 1 by 2 by 3 cube by 4 square. Reciprocal multiplication, what you will get? 1 by 2 times 4 square, 16 by 3 cube, 27. You will get 8 here. So again 8 by 27. So volume of cone divided by volume of sphere is equal to 8 by 27. And that's also we proved. So this is the last part of this question, and we are moving to the next part, absolute maxima and absolute minima. That is the last part of this chapter. So what is the difference between absolute maxima, absolute minima, and local maxima and local minima? So listen, if there is a function like this, listen, if there is a function like this, okay, it starts from A, ends at B, it's C. So you can see this value f of A, when you're putting A for the function, you will get this value f of A. When you're putting C, you will get what? F of C. This is the highest value and this is the lowest value for this function. Ready? And this function is from A to B. This function is from where to where? Sorry, A to B. Okay. So this is critical point. This is not critical point. It's end point. This is also end point. Ready? Listen. This is critical point. This is critical point. This is critical point. This is critical point. Critical point means that's where the function is changing its behavior from increasing to decreasing, or decreasing to increasing, or increasing to increasing. At that critical point, it's point of inflection. So at the critical points, you can find what? Local maxima. So this is your local maxima. Ready? And this is your local minima. But below the local minima, you have another minima. Below this, you have another minima. This is what we called absolute minima. Ready? It's not critical point. It's not critical point. It's not critical point. But this is it's an end point. At that end point, this function is giving you the lowest value, so we call it absolute minima. And you can see this is what critical point. At this point, you are getting the maximum value of this function. We are calling it local maxima as well as absolute maxima. Absolute maxima. So what is the catch here? Listen, a local maxima or local minima can become an absolute maxima or absolute minima. Ready? Because critical point can become the biggest critical point, the maximum value out of all of this, like this. Ready? Or listen, if this is the lowest value, if this is the highest value, this end point is the highest value, then this is not your absolute maxima. This critical point is not your absolute maxima. Absolute maxima is at the end point B, that is f of b. So absolute maxima and absolute minima can occur at critical point as well as end points, but local maxima and local minima is only exist at critical points. I'm not calling it local minima. I'm not going to call it local maxima, because that is just end points. If the critical point is there, then only we can call it local maxima and local minima. If the critical point, if a point is not a critical point, if it is the maximum one, we can call it absolute maxima but not local maxima. If a critical point is there, that is the maximum of all maximum, then that critical point is local maxima as well as absolute maxima. So if there is an interval, then only you need to think about absolute maxima and absolute minima. If there is no interval, the absolute maxima and absolute minima and local maxima and local minima only occur at your critical points. But if there is interval, the absolute maxima and absolute minima may occur at the end point, but the critical point will not occur at the end point, unless it's a critical point as well. Also, it's a critical point. Okay, so just go for this question and you will get more clarity. Listen, find the absolute maximum value and absolute minimum value of the function f given. Anyway, you have to differentiate it. 2 sin x cos x plus sin x. That's what you get when you differentiate it. You need critical point, yeah, because it have starting and ending point, as well as you need to check at where critical points also. So f dash of x equal to 0 at critical point. So 2 sin x cos x plus sin x equal to 0. So you can take the sin x out. So you will get 2 cos x plus 1 is equal to 0. So you may get sin x is equal to 0, or 2 cos x plus 1 is equal to 0. Sin x is equal to 0 in this interval only at x equal to 0 and pi. So these endpoints are what also? Critical points also. Endpoints as well as critical points. Ready? Then cos x is equal to minus 1 by 2. When you will get cos x is equal to minus 1 by 2 at pi minus pi by 3, or you can say that is 2 pi by 3. Ready? So x equal to 2 pi by 3 also. So in this interval 0 to pi, in between we have 2 pi by 3 here as a critical point. So you got 3 points, 0, pi. Both are what? End points as well as critical points. And this point is only what? Critical point. This is what? End point and critical point. This is what? End point and critical point. If you got this question like this, you don't need to go for the second derivative to find the maxima and minima. You have to directly put what? F of 0, f of 2 pi by 3 and f of pi. What is f of 0? When you put 0 in this value, you will get sin 0 is 0, cos 0 is 1, 0 minus 1, you will get minus 1. 2 pi by 3, put sin 2 pi by 3. Sin 2 pi by 3 will be root 3 by 2, the whole square, minus cos 2 pi by 3 will be 1 by 2, it's negative 1 by 2. negative 1 by 2. Anyway, it's positive, it's greater than 0. Sorry, we just put it 3 by 4 plus 1 by 2, you will get 5 by 4. Ready? Yeah, it's bigger than this one. And the last one, when you put pi, sin pi is 0, cos pi is minus 1, you will get 1. So you need absolute maximum value and absolute minimum value. So out of these three values, which one is the biggest value? 5 by 4 is more than 1. 5 by 4 is what? More than 1. So this is absolute maximum. So this point, at this point, absolute maximum is there as well as critical point. Absolute maximum at a critical point. And the minimum value is minus 1 at 0. So this is end point, critical point, and what? Absolute minimum. Ready? And this is also local maximum. But this is not, that's a catch, not local minimum, because, yeah, it's local minimum also because it is, sorry, it's local minimum also because it's a critical point as well as. So it's a local minimum also. Fine. Local minimum. Sometimes if you didn't get this as your critical point, at that time you will not call it what? Local minimum. It is only absolute minimum. When you're directly putting, you are getting the lowest value, but when it is not a critical point. So this is where how you find absolute maxima and absolute minima. Listen carefully. You don't need to go for second derivative, first derivative, anything. Find the critical point, take the endpoints. I'm just concluding it like this. Find the critical point, take the endpoints, put all in this function. Biggest one, absolute maxima. Lowest one, absolute minima. That's it, nothing else. Okay, we'll do one more question. So least value of the function, they gave you the interval also. So anyway, they didn't mention anything absolute or lowest one, but if they gave you endpoints, if they give you this interval endpoints, you have to consider what? That also. That means they are asking for absolute maxima and absolute minima. So what is f dash of x? Minus 2 sin x plus 1. Critical point at f dash of x equal to 0, it's minus 2 sin x plus 1 is equal to 0. So minus 2 sin x equal to minus 1. Sin x is equal to 1 by 2. In the first quadrant, x will be what? Pi by 6. So you got the critical point, pi by 6. Ready? Now what? We have to put these values in it. F of 0 is the first endpoint. This is just endpoint. This is just endpoint. This is critical point. These are not critical points. In the last question, these endpoints are critical points also. But in this question, both are endpoints only. Both are endpoints only, not critical points. Only one critical point. You're putting endpoint, you're putting critical point, you're putting the last endpoint. F of 0, you will get 1 into 2, 2 plus 0, you will get 2. F of pi by 6, you will get 2 into root 3 by 2, 2 into root 3 by 2 plus pi by 6. You will get pi by 6 root 3, pi by 6 root 3. Then the last one, you have to put pi by 2. Cos pi by 2 is 0, you have to as pi by 2. So listen, out of these two, you need to find least value, right? Out of these two, this is small and this is big. Now we need to check what is this, what is this. So we are not able to find the value. If you can calculate the numbers like pi as 3.14 and calculate it and identify this number is more than pi by 2 or less than pi by 2. You can identify that, but I'll give you one shortcut. That is, when you put this value in second derivative of this, what you will get? F double dash of x will be what? Minus 2 cos x. That's it. When you put it in here, pi by 6, this critical point in here, you will get minus 2 into root 3 by 2. It's greater than 0. It's greater than 0. Therefore, it's max. It is what? Max. This pi by 6 is a local maxima. It's a local maxima. It's a local maxima. So it will not become least value. It's max value. So the least value is what? Pi by 2. Then your answer is what? Pi by 2. Sometimes if you feel hard to calculate the value, you can go for the second derivative for the critical points only, not the end points. End points you have to calculate. But if you got the critical points, if you're confused in critical point, go for the second derivative, put it in. If it's maxima, it is the maximum thing, and you can choose out of this. This is the smallest one. Pi by 2 is the least value. Okay, so that's all this chapter. So I've gone through all the kind of questions. You have to practice all these types of questions from your NCERT. Also get some previous year questions, all of them. If you want, you can come here at Excel and collect our maths revision module, practice module, everything, and you can practice it. You can score the full mark from this chapter. Hope you all enjoy this session. See you in the next class. Bye all.